Assalamualaikum and hello everyone. So today we are going to discuss about the IDP talk, which the title is the electrical analysis and component selection. So of course, when you are doing a project with your IDP, your project must consist of a mechanical element, electrical element, and maybe software part elements. So when it comes to the electrical parts elements, of course you have to do the analysis on the electrical part and how to select the component for your project. So this talk of the title electrical analysis and component selection is going to give you a brief overview. So we are not going to go in detail, but give you a brief overview on what are the important parameters or the important consideration that you should taken into account when you are doing the analysis, especially the electrical parts and the component selection for your project. So these are the topic that I'm going to discuss today. We have 3 parts here. The first part is understanding your system. Second is electrical analysis part, and the third one is component selection part. So we start with the understanding your system. So we have 4 points here. You start with a problem in your hand. Maybe the problems come from your supervisor or you read it somewhere else. Anyhow, you have problem to solve, and then after that you have a system understanding. You go to the system development, and the last is you are going to create your own prototype of your system. So if you see from the slide here, you can see that the system understanding have a bigger circle than the others. Why? Because this is the most important part that you should spend more time on understanding your own system, your own problem, before we proceed to develop the system to solve the problem. So let's say you have a problem about your robot or your machine is easily heat up. So before we solve our problem, we have to understand first what kind of configuration that is previously being used that caused this problem. So we have to understand first the fundamental and the theoretical part as well as the practical part of your system. And after that, there are basic parameters that we have to consider inside your system, which is the system load, which is consists of maximum current drawn on your system, maximum torque, and force, allowable tolerance or resolution for your system. For example, we are designing a conveyor system, a conveyor that is for pick and place operation. So how far can we allow the offset tolerance from the position of that we want plus the error? So we have to consider all this kind of thing. And every system, every mechanical system that you design that consists of electrical part, every machine, you have to know that what kind of machine you have. Is this a rotary machine, translational machine, AC system or AC from the AC power supply or DC power supply, the mathematic system dynamic of your system itself, as well as the control system. How do we control your system to make it automated? So you have to understand or to define your system first. And we go with the electrical analysis of our system. So for the electrical analysis part, there are 2 parts that are very important. First is how do we calculate the torque of our system, and the second, the power that is required by our system. So if you miscalculate these 2 things, means that you are going to have a problem later when you are developing your system. Is that if I wrongly calculate my torque required for my motor, then my system cannot move at all, and it will cause my money is being burned because the system is not functioning. So this is the important thing. And before we go back, or before we go further with the torque requirement, so we go back to the previous classical physics theory, which is the basic Newton second law. What does the Newton second law say? So the Newton second law said that the summation of forces or torque will be equal to mass or inertia times the acceleration. So if you see from here, for example, we are designing a mobile robot, a car mobile robot, whereby the car is required to go uphill. So in order to go to the uphill position, so we have to consider that the force that we want to supply to our vehicle to go to uphill must be higher. If your force is lower than the load requirement, then the vehicle cannot go uphill. So we have to consider it, or what we call as a force balance equation. So you have to understand this one first. And if we understand the force balance of our equation, then we need to see the actuator requirement of our system. For example, you have the system. This is your system. So in order to move your system, this is the load torque that is required by our system. So in order for us to move the system, our drive torque must be higher than the total load from our system itself. So what I mean by the total load, you consider the mass of the machine, the load from the actuator itself, the initial load, the friction coefficient. So we must make the system that is supplying the power to move it must be higher. And how to do that is we can use a sensor, maybe force sensor, to estimate the total torque demand of the system. So with that, when you have a machine, you estimate your machine size, then you can estimate the torque that is required, and then after that we have defined our actuator requirement of our system. And after you have the estimation on what is the amount of torque that is required on your system, the second question, which motor is suitable to drive the load? And based on our requirement, what kind of electrical system is suited to the machine, to our machine? Is it AC system or DC system? So you have to understand, when we are designing a system, you have to understand that every design comes with cost. Maybe the perfect motor comes with a very high price. Maybe cheap motor is not reliable. So you have to balance between these two requirements. We don't want to under design our system. We don't want to over design our system. We have to make a harmony design of our system. For example, the servo or stepper motor, they are very precise, easier to control because they already have pre-configured with the angular control motion for the motor itself, but it's very expensive. So for IDP, you have a very limited budget, 500 ringgit per project, so you may have a constraint to use a stepper motor, or you want to use a DC motor with encoder. Then the problem is you have to understand how to manually tune your system so that your system achieve desired performance. This one is cheaper, but of course it comes with a higher complexity compared to the stepper motor. So it depends on the system requirement and your priority. And of course, for the motor, normally we will see what is called the steady state operating speed of the motor. So when we select the motor, normally in the datasheet you will have requirement for the steady state speed of the motor. So with that, you have to define that what kind of speed you want your motor to run. For example, you are designing a conveyor system just now, so you want to estimate the pick and place operation. Your item is moving at what velocity, and if you want to your item to move at what velocity, also you have to understand, if I want to move at this A velocity, what kind of torque that I required based on my previous calculation. So this one we have to balance and see the datasheet of the motor and check out the torque and speed requirement of the motor, whether it satisfy our requirement or not at steady state operating speed. And also we have to check the current requirement of our system. You know, when we start the motor at a first condition, the current value is very high because the motor have to overcome a very high amount of starting load. So you will have a higher spike of current, and then gradually when the torque is reaching steady state operating speed, then the current will gradually decrease and decrease until at the steady state operating current. And we are going to see, based on the motor selection that we select, at certain speed, at certain load requirement, what is the amount of the current. And let's say in order to get the required speed and torque that you required, maybe suddenly your system need to run at 200 ampere. So but you are not designing a system that goes until 200 ampere. Maybe your estimation is only 2 ampere current only, means that is not meeting your system requirement. So you have to adjust back your system so that the speed, the torque, the current all are meeting for your system. And we have to consider, normally the student, when they are designing the system, normally you have one load, then you consider, okay, this is the current only. But you have to remember that, for example, you have one complete system, you have multiple load requirement inside your machine itself. Maybe this load is for pick and place operation, this load is for another operation. So you have to consider every load that is involved in your system and the total power supply that is required. Means that you have to consider, for example, if one system is requiring 1 ampere of current, another system requiring 3 ampere of current, so we need power supply that can supply us 4 ampere maximum current. Or maybe our load is AC load, but our supply is the DC supply, so means that we need an inverter for our system. So you need to check out the inverter requirement of your system. So when we use the inverter in our system, we have to estimate the efficiency of our inverter, and the power loss inverter should be calculated as well, so that we can estimate precisely what will be our power conversion to the system, and the loss of our system should be minimized as possible, because we don't want to waste the energy from our supply. And the step number 5 is the power requirement of the system. You have, based on the previous requirement, you have to calculate the maximum current of your system, which is we did it previously, and we have to determine what kind of voltage value we want to run into our system, and we can estimate the total power that is required by our system using this equation. The power is equivalent to current multiplied with voltage. And of course, when we calculate, for example, your system need 100 watt of power, This is on theoretical, but you should consider the power loss from your system as well, due to the motor windage loss, iron copper loss, or wiring loss. The longer the wire, the higher the loss you have. The gear backlash also will contribute to the loss that is consuming more power, and the friction as well. So if we want to see, for example, my theoretical calculation is 100 watt power, for maybe plus loss, maybe my loss is about 5 watt of power. So I need at least 105 watt of power to run my system, considering the loss. So it is important to calculate or estimate the loss to ensure the input power is able to drive the load. So if you did not consider the loss, then you have a problem to move your system. And of course, the step number 7, the wiring part is very important. So you will have a power supply cable, you will have a signal cable, and of course your system must have a proper grounding. And if you have any signal line, very speed signal line, consider shield it with a grounding. Is that we don't want any electromagnetic interference that is jeopardizing our signal line. And the longer the wire, the higher the noise. And if our wiring is longer, for example more than 5 meter for signal line, we will have a very significant voltage drop from the sender to the receiver, and you may receive a wrong signal. So we need to use differential signal transmission protocol if we have a very long signal line, and try to put a distance between the power line and the signal line. This is to avoid any electromagnetic noise into our signal, which will cause error when we do the programming later. And of course you have to put the safety factor, fuse, and other safety precautions. And next we are going with component selection. So we have defined every parameters previously, so we have to know. For example, in your machine, the most important part is the motor. So motor, you have a DC drive motor or AC drive motor. So each of the motor has its own advantages or disadvantages, as you can see on the slide. And if you see here in this slide is the torque measurement. This is, for example, the case study on how do we want to measure the torque. So if you see from here, the way we measure the torque is we try to do a torque balance equation. Is that we try to see the value of load that the motor can get balanced. So for example, here we have 1 centimeter of radius for our motor shaft that can balance the 1 kilogram of load. So right now we can say that our torque right now is equivalent to 1 kg cm. So eventually if we convert into the Newton meter, you will get 0.0981 Newton meter in SI unit. So this is one of the example how do we do a torque balancing in our system. And I would like to remind again, the safety is very important when we are doing any project. So I would like to emphasize again, the wire thickness, the fuse must be properly calculated based on the maximum current requirement. For example, the wire thickness, you estimate your system is 2 ampere of current, so you can multiply this 1.5 of wire thickness as a safety factor, and the fuse is to prevent damage to your system. Okay, so as a summary, I have shown to you several steps that is required for you to analyze, especially on the electrical part of your system, the power requirement of your system, as well as the safety factor. Of course, you don't have to do a very detailed modeling or analysis, but at least basic calculation to prove that your system will be working when you are buying this component is very important when you are doing the project. Okay, so I think that's all from me, and I wish you guys all the good luck for doing the IDP, and stay safe, and hopefully you will success and complete your IDP subject. Bye.